Hi friends, welcome to another day for triangles, and we are going to now continue from where we left yesterday. So let's get into it.
Hi friends, so let's start from where we left off yesterday. Let's move on to another question. Let me just figure out which question we are looking at. Yeah, we are looking at question number 6 in figure, right? So let me just make that figure first here. This is the figure A, B, C, D, E. Okay. What have we been given here? So what I do is when I usually solve a problem, right? So I read the question and I write it in this manner. I write what is given, then I write what is to prove, and then I write proof. You can start from proof also, that's not an issue. But it sort of sets out the things. So what is given? Triangle ABE is congruent to triangle ACD, right? Triangle ABE is congruent to triangle ACE, these two triangles, right? Triangle ABE now when we look at this, what does it mean? All sides are equal, corresponding sides are equal. AB is AC, B is CD. I'm just writing it down as of now, whatever it is. As of now, my focus is not up this thing, right? So let's see, ADE is similar to ABC, right? A, so we know for this, in our minds, we already know that this angle is common. So that's there. Now, either we have to prove that these angles are equal, right, by AA or AAA, whatever. Or we have to, the other methods could be SAS, that we show that AD by AB is equal to AE by AC. Then SAS would come into picture, or SSS, that AD by AB, AE by AC is equal to DE by BC, right? ये सारे आपके pictures हैं. आप, you know what you can do all, but let's just take the simplest one. If you want to show that all the angles are equal, it means that we have to show that this is parallel to this. We know how do we show that this is parallel to this by theorem 6.2, which we learned in the previous class. We look at the proportions. So let's look at the proportions AD by DB. If this proportion AE by AC, right? If this becomes equal, then we can say DE is parallel to BC. And if DE is parallel to BC, then this angle D is equal to angle E, angle B, angle E is equal to angle C, and angle A is common, right? So hence this will be done. But let's see whether this is coming or not. So what is AD by DB? AD is, we can see, is AE itself. And what is DB? Sorry, ABE, right? AB equals. And what is DB? DB is not given, right? So how else can we write this? We can write it as AD by AB is equal to AE by AC as well, right? Now, are we able to prove this? Net we have to be able to prove this. What is AD? AD is AE. So numerator is proved. AD is A. This is equal to this. Now the denominator is AB and AC, which is also there. Basically, AE is AD, AB is AC. This ratio is equal, right? So then, hence, this is there, this is there, this is there. I hope this is quite clear. I have not mentioned in the traditional form. I'm trying to show how you're supposed to think. Right? You can think in any which manner that you want to think, right? But I'm just showing you some ways of thinking. You can think in other ways also. Right? So that's not an issue. Now let's move on to the next question. Just trying to make the diagram here. Sorry, it was very funny, I had actually drawn all the questions so that I thought we can go through these more efficiently. Then what happened is that I forgot to save this, right? So I forgot to save it, and hence I'm now having to draw it in the class. I could still pause and make it, but I'm fine with it. I'm also able to take you through the questions, and this is how you are also going to actually do it, right? So hence should be a win-win situation. So let's look at this. In this figure, this is the figure that has been given. Okay. There's another altitude. So these are two altitudes. AE, AD, perpendicular to CB, and CE, perpendicular to AB. ठीक है? Point P पे intersect कर रहे हैं. So let's see. There are a number of things we need to prove here. We can pick one or two questions, and the rest you can do it. Right? So we have to take this chota triangle AEB and CDB. This is also 90 degrees. We already know this is not CD. This is CDP. Okay. So here we already know that angle AEP is equal to angle CDP is equal to 90 degree. It's already given. So this angle is also already equal, and this angle is equal. Hence the third angle will also be equal. So hence it is similar. AA or AAA, similarity criterion. Now let's look at the second part. Triangle ABD, similar to triangle CBE. That is what we have to prove. So what is triangle ABD? This triangle. CBE, this triangle. So again, it's quite similar to the previous question. Do you want to do it? I don't think I want to. B is equal to B, already given. D is equal to E, already given. So yes, let's move on to the next question. AEP, that is this triangle, is similar to ADB, that is this triangle. So again, A is already equal. Okay. E is already 90 degree. D is also 90 degree. So this is that. I think we should move on to the next question now. Right? Okay. Moving on to the next question. Yeah. Let's move on to question number 11. So this is a triangle. AD is an altitude, and there is a point E on the line segment which is extended such that we have drawn there. This has been drawn basically, right? So what is given? It's also given that this is an isosceles triangle with AB equal to AC. We have to prove okay, let's move on to the proof. Triangle ABD, right? ABD and ECF. When AB equal to AC, we know that angle B is equal to angle C. This angle and this angle are equal because of the isosceles angle triangle. So if you look at this, I'm just showing you again how I am working right now. फिर लिखने में तो आप लिख ही लोगे, तो साइड में आप थोड़ा रफ करके कर सकते हो, and that's what I used to do, and then used to write down. Or in your mind you can do it, and then you can write down. So one angle is already equal, right? Now let's look at any other angle which is equal. I think all the questions are very similar, man. See, angle BDA is equal to angle CFE, right? Equal to 90 degree. And this angle is already equal. A. So basically what is this? ABD is equal to angle ECF. This angle is already 90, ABD, because this is 90, this is 90, right? Angle ADB equal to angle ADB equal to angle EFC, 90. I mean, obviously it means this is equal to this, right? Anyways, so by AA triangle property itself, we are being able to prove it. Let's move on to another question. It's given that, so they have not drawn a figure, I am drawing it. It's given that there is a triangle ABC and there is a point D such that this angle is equal to this angle, that is angle BAC equal to angle ADC, right? So let's look at triangle ABC and this triangle ADC. I am not writing deliberately because I want to see symbolically. So it is C. C is common. C यहाँ भी आ जाएगा. A के साथ कौन सा है? D है. So that means that this is how I write. So let's look at, these are already similar, right? They have two angles common and one is this. So it's similar. I am not writing the steps. I am telling you. One is this and one is this. Right? So it's similar. So if it's similar, so what does it mean? AC by DC is equal to DC by AC. Rearranging, AC square is equal to DC into BC. This is what we have to prove. If you look at the question, this is what we have to prove. In the question it is written CA square is equal to CB, which is this, and CD. Just the order has been changed. So I think these were the questions that I wanted to write for this chapter. There are some questions in the exercise and maybe some questions in the examples that I have not taken you through, right? But we can go through them if you have any doubts, if you have any questions, if you have any comments, and if it is required, I can make another video on it. They are quite similar. Once you get hang of it, it's quite similar. So let's just revise what we've learned so far in the many classes that we did. Okay, two figures which have the same shape but not necessarily the same size are known as similar figures. Okay. Congruent figures are a subset of similar figures. What does it mean? All congruent figures are similar but all similar figures are not found. Two polygons of the same numbers of sides are similar when what? Angles are equal, corresponding angles are equal, and corresponding sides are in the same proportion. If a line is drawn parallel to one side intersecting the other two sides in two distinct points, then it divides the other two sides in the same ratio. Converse of it, a line which divides two sides in the same proportion is parallel to the third side. Right? Sixth point, for triangles, it can be similar by AA criterion, and that implies actually AA criterion as well. Then we have for two triangles, if, like this was the one, right? Sorry, not this one, SSS. And ninth one was SAS, right? So what did SAS say? If SSS say include triangles, the corresponding sides are in same ratio, then the corresponding angles are equal, and hence the triangles are similar. And if one angle of the triangle is equal to one angle of the other triangle, and the sides including these angles are the same ratio, then the triangles are similar. See, when the triangles are similar, so basically for triangles we don't need to have the same thing as polygons if the sides are in proportion or implies that the angles are equal. So basically, if two triangles are similar, angles are equal, sides are in proportion, right? That's what it is. But we don't need to necessarily do both of it. We can take it in combos, like if we just know the angles are equal, or if we know that the sides are in proportion, then it implies the other thing also. Or one of them is this, that only if one of the angles is equal and the other, only two of the sides are in proportion, then also we can prove they are similar. So I think I have tried to do a lot of comprehensive questions. However, if I come across any question, or if you guys come across any question which is in this chapter and you have any queries, doubts, let me know.
Hopefully आपको ये सारे concepts समझ आए हों. You've understood what I've taught today. If you have any questions, comments, queries, any doubts, any feedback, anything you want to say, let me know in the comments below. Also, how did you like my new way of teaching? Let me know on that as well. It was the first time, and I actually didn't practice, I just went on with it. First time working on a drawing tablet, first time working on a computer in this manner. I just went with it. Literally, I have not practiced, so it might be evident in the videos, but I did my best, and I hope you are able to understand what I have taught. And let me know, maybe you can give me certain tips on how to make it more smooth. I think practice will make me perfect, but I'll wait for your tips. Till then, like, share, comment and subscribe to my YouTube channel.